Hello friends, welcome to Pravegaa Education. My name is Kunal Jaswal and here I am again with my video number 4 for the League of Polarization of the Light. As you know that we are basically making a video, the very short videos on the JAM syllabus and the CSIRNET syllabus, and in this league currently I am delivering the lecture on the polarization of the light. So in this league I am here with the lecture number 4, basically based on the circularly polarized light. So in the last lecture, that's been in the lecture number 3, we have seen what is plane polarized light, okay, and how mathematically we can get the equation for the plane polarized light, and what is the basic condition on the phase difference and the amplitude. So similarly, let's discuss about the circularly polarized light. So in the last video, we have derived a general equation, that is Ex square over A square plus Ey square over B square minus 2Ex Ey over AB into cos phi, and this is equals to sine square phi. This is the equation we have found it out. Okay, I don't think there is any need to derive this equation again. What is phi? Phi is the phase difference between the component along the x and along the y. Okay, so phi is the phase difference. What is Ex and Ey? Ex is the electric field in the x direction, Ey is the electric field in the y direction, and AB are the amplitude of the respective electric field. That means A is the amplitude electric field in the x direction and Ey is the amplitude of the electric field in the y direction. So as you can see in the figure I have mentioned here, that the tip of the electric field on rotating, basically forming a circle. So this type of light ray is known as a circularly polarized light. So how the mathematically we can get this? Let's discuss on this. So if we superimpose a condition first on the amplitude, so on amplitude, so if amplitude we take equal, that is A is equal to B. So if I write like this, A is equal to B, it's a condition on the amplitude, and condition of the phase difference, that is phi. Phi is nothing but the integral multiple of the pi by 2. That is phi is equals to pi by 2, 3 pi by 2, 5 pi by 2, and so on. If these two conditions we superimpose on any light ray equation on the electric field, the resultant light will be circularly polarized light. Okay, now let's derive this. Put this to this condition in this equation. So what we will get? If A is equals to B and phi is equals to pi by 2, let's take 5 by 2. So this component will be 0 because cos 90 is 0 and sin 90 becomes 1. And if amplitude are the same, so it will be nothing but Ex square plus Ey square is equal to A square. And this is the equation of circle, right? This is the equation of the circle. So this is the main condition, what you must know as far as your exam is concerned, right? You can get many questions on the basically based on this condition, that the phase difference should be integral multiple of the pi by 2 and the amplitude of both the direction, both the components should be equal. If this is the condition is followed by any electric field equation, then the resultant light ray will be nothing but plane polarized light. Sorry, it will be circularly polarized light. Okay, it will be circularly polarized light. Circularly polarized light. Okay, so this is quite useful information for you guys. Okay, in your JAM exam, in your CSIRNET exam, the question directly asked from all this concept. That's why Pravegaa Education is providing you a very useful information in a very short duration of the time. So please follow, and I hope this type of video will be quite helpful for you. Thank you.